Good afternoon, everyone. Today, every day you should join through the GLearn. Now it's changed from Moodle to GLearn. So everyone, no need of confusion. Still 30 members only joined. So what we discussed, types of reviews we discussed, right? So we discussed about different types of reviews. In that, we discussed about software peer review, code review, programming walkthrough, technical review, and inspections are there. Then software audit reviews there by the managerial people that we explained. And what is the need of formal technical review to identify the errors in the early stage, right? Before you're going to start your design implementation itself, during the design phase itself, you can identify the errors. That is called that is the use of technical reviews. So what is the need of identifying the errors in very early stage? Is there any plus points? Of course, that I will explain through an example. The cost impact of software defect. What is the cost impact? Cost impact means when you identify the cost. Suppose if you identify errors, suppose if you identify the errors in the late stage, you have to spend more money for debugging and correction because the impact is more. But if you identify the same errors in preliminary design or detailed design, you can save a lot of money and time. 50 to 60% of errors during the software process. When you identify that error, so that we'll illustrate through an example. This is actually the conclusion. Suppose an error is uncovered during the design phase. It will cost around 1 monetary unit to correct it. At the same time, suppose if one monetary unit, you need to correct one error which you are identifying at the initial phase, but just before testing, it becomes 6.5 unit. If you identify the same error, you need to spend 6.5 unit to correct it. During the testing, just before testing it is 6.5, but during the testing it immediately changed to 15 units. And after release, if you identify the same error, you need to spend some 60 to 100 unit. So initial monetary unit you need for debugging was initial means in the preliminary design time. If it was 1 monetary unit, if you identify the same error in the last phase, and after the release, you need to spend nearly 60 to 100 unit. So you can see the amount you need to spend is huge, right? You need to multiply it with 60 to 60 or more than 60. So the effect you can identify from that. Through an example, I will explain that. This is a defect amplification model. Suppose this is the defect amplification model. In this, it contains 3 columns. First is error which is passed from the previous module. The second is some errors which is passed but that is amplified by a factor of x. Means their impact is 1. If suppose if one error passed 1 into x, it may create an effect of x value. X value may be 3, 4, 5 or whatever it is. So you should multiply with it. Then some errors which is newly generated in that phase itself, and some errors we are detecting. % efficiency for error detection. And after error detection, some that errors we can remove, and the remaining errors which is passed to the next phase. So this is a defect amplification model. Remember all these four field error which is passed from the previous stage, then amplified errors by a factor of X, a newly generated error, then percentage of errors which we are detecting in that phase. Are you listening?
Yes, ma'am.
So here in this example, this is the defect amplification removal example. You can see the 0 errors are transferred from the previous stage. 0 errors are amplified because it's preliminary design phase. There is no phases before it. So 10 errors are generated in the design time. Design time, you did not notice. So 10 errors, it's generated there. So 0% error you detected and removed. So the entire 10 errors are passed to the next phase. In the 10 errors, 6 errors are passing as it is, and that remaining 4 errors are amplified by a factor of 1.5. That is the impact factor. Then 4 into 1.5. That is the error affected. Then 25 errors which are generated in that phase itself. So what is the total number of errors? 37, right? 37 is the total number of errors. Means 6 plus 25. 31 plus 6, 4 and 1.5 is 6, then 37. 37 errors are there. In the 37 errors, 10 errors are passed to the next code unit as it is, and the remaining 27 errors are passed by a factor multiplied by 3. This is the impact factor. So 25 errors are generated in that phase. So what is the total number of errors here? 27 into 3. 27 into 3 is 81 plus 35. That is 116. Among 116 errors, 116 errors are generated in the total errors are here in the code unit or unit test time. In the 20% errors are corrected here, means into 20%. That is 23 errors. 23 errors we detected, corrected here. So 116, from 116, we moved 23 errors. Then the actual value is 93. The value is 93. But here it shows us 94, it's a mistake. So 93 errors are coming out of the phase. So next phase is integration phase. In integration phase, total 94, okay, this entire calculation is done using 94. So otherwise, the actual value is 93. So 94 errors are coming here, and in the 94 errors, there is no impact factor, and no new errors are created in this phase. So the total number of errors is 94. In the 94, in that 94, 50% of errors are corrected. So 94, 50% error means 47. Then remaining 47 errors are there. That is passed to the next phase. That is validation test. There again, no newly generated errors are not there. For 47, 50% of 47. What is the value? 47. 50% of 47 means 23.5. Means 24. So 24 errors. 23.5, they round off as 23 only actually here. Okay, in case of error, 23.5, 23 they took. So 47 minus 23. is 24. So 24 errors are coming out, and systems tested. Again, 50% of that is corrected. That is 12 errors are removed. Again, 12 errors are there, latent errors are there. That is passed to the next step. Okay. So this is the amplification removal model, defect amplification and removal. Here, defect is amplified here, and it's removed in the last phase. So after removal, the errors, remaining errors are passed into the next phase. So in last, the rated errors are 12. What is the problem here? Why we got 12 errors at last? Because we did not remove the errors in the initial phases, right? Here, preliminary design time and detailed design time, there is no error detection and correction. Only start from the unit test onwards, unit test, integration test, and validation test time, we corrected some 20, 50, and 50% errors. So when it comes to next defect amplification model with review, at the time, how many errors are passing through this, and how many errors we are detecting and removing in each and every phase. Compare these two. Here, 10 new errors are there in the preliminary design. In that, 70% errors we are detected and removed. 10 means out of 10, 7 errors we detect and remove, and 3 are remaining. So the 3 is passed to detailed design. In that, among 3, 2 errors are passed as it is, and 1 with a factor of 1.5. Then 25 errors are newly generated. Then what is the total number of errors? Total number of errors is 1.5 plus 27. That is 28.5. In the 28.5, 50% of errors are corrected. Means in 28.5, 50% means 14. 14 errors are corrected. The remaining 14 errors are there. That is passed to the, but here showing us 15, where the actual value is 14. 1.5 plus 2 plus 25. 28.5. That is a mistake here. So you can correct this value as 40. So 50% is corrected, and the remaining 40 is passed to the next phase. Then again, that one 4, okay, the values which are passed. Can you see around, suppose if it is 15, okay, actual value is 14. This is a printing mistake, but it's continuous. They are giving the same value. So I will explain through the same value, but here the value is 14 only, right? Okay, then here suppose if it is 15, 5 values are passed as it is, and 10 values amplified by a factor of 3. Then 10 into 3, 30. 30 plus 5, 35 plus 25. 30. Okay, 30 plus 30. So 60. And total 60. 10 into 3, 30 plus 25 plus 5. 30. 30 plus 30, 60. In that 60, 60% errors were corrected. Means 36 errors are corrected. Then remaining 60. 24 errors are there, right? So 24 errors are there. So these 24 errors are passed to the next next phase. In the 24 errors, 50 errors are corrected. No errors, newly generated errors are not there in integration test time. Only 50% errors are corrected. That is only 12. 12 errors are corrected, and again 12 are there, which is passing the validation phase. Again, 50% corrected. Then remaining 6 are there. 6 is passed to the next stage. System test time also 50% corrected. Latent error is only 3 instead of 4. Instead of 12. In the previous example, the value was 12. Here the value is 3. You could see the difference. Here we done the error correction in the first phase, the preliminary design time and the detailed design time. We done error correction. That is difference. But here we done, we did not do any kind of only 0, 0, 20%. But in the last phases, we done 50% correction. But what is the problem? Then already that errors are passed to the next phase. And again, it generated the impact factor affected, means that error which is affected in that module is more. And again, the number of errors are more. So at last, the latent errors are more comparing to the with review, without review. Both cases you need to consider. So the latent error is very less if you detect the error in the early phase. That is the point. Is it clear? So this is an example for the need of reviews, formal technical reviews, or the other different types of reviews we learned, even the encoding inspection. Those reviews, why we are conducting those reviews in the early stages, we can identify the errors. So that is the need. The next is review report and recording. That this thing actually I explained. Review guidelines also explained. What is review guidelines? During the FTR, the viewer actively record, review the product, not the manufacturer. That I explained yesterday. We should review the product, not the one who created that. You should not judge the person, you should judge the product. Then take the written notes. Whatever is there, what are your findings, you just take the written notes. Then limit the number of participants and insist upon advanced preparations. You should come up with advanced preparation for the meeting and develop a checklist for each product that's likely to be reviewed, and allocate resources and time schedule for FTR to maintain the time schedule. We should study before you are going to judge or review someone. You should study the system. Then only you can judge that what they created, right? So that's it. And allocate resources and time for the FTR and conduct meaningful training for all the reviewers in order to make the reviews effective. And reviews which serve as the base for current reviews being conducted. Whatever, suppose if you done similar type of reviews before, you just collect the information, and that information will help you in the coming project evaluation. Set an agenda and maintain that, and separate the problem area. Do not attempt to solve any problem. You should not solve problem during the FTR meeting. At the time, you just identify the problem. And later, you have to record all those problem area, and in later stage, you can give time to the developers to find out the solution. Limit debate and rebuttal. You should not argue with the people. While conducting review meet, a group of members, the review panel members, they review your product and give you some suggestions, and they will either accept or reject your product, and otherwise they will recommend some modifications. You should do that. You should not argue with them. So these are the main guidelines you need to remember. So next, Next is review after review guidelines. Agile review, I already explained what is agile review. Agile review is same like normal prescriptive model reviews, but this one will come very frequently, and always you should consider all the suggestions and requirement suggestions. Okay. The next is software quality assurance. Software quality assurance means every organization has to give assurance to the client regarding the process, activities, methods, and work items. All these things should follow some standards and guidelines to achieve the quality. So that is the quality assurance scheme. Software quality assurance plan comprises of procedure, techniques, tools that you can employ to make sure the product or service which meet the requirements which described in the SRS. At the same time, it should be a quality product. So that this quality we could not create in a single phase. We need a background work from every process, task, methods, whatever tools you are using. For everything, you need to follow the exact guidelines and standards. Then only you could achieve that. So this is the software quality assurance system. In that one development phase, every phase, baseline system creation, that means modeling time and production time and marketing time. Every time you should follow the standards to create the quality. Then SQA plan, when you create an SQA plan document, it contains these sections. Purpose section should be the reference section should be the software configuration management section should be the problem reporting area, and what are the corrective actions you are suggesting, tools, techniques, methodologies, code control section, and you need to collect all the information, maintenance, retention section. Testing methodologies should be there in the SQA plan. So when it comes to SQA activity, there are different activities which support the software quality assurance. You just remember these points. Create an SQA management plan. Means first you should go with the proper plan. Whatever thing you need to execute, you need a strategy to execute. So that we should mention the plan. At the time, it includes laying down a proper plan regarding how the SQA will be carried out in the project. At the same time, other engineering activities which are carried out and also include ensuring that you have right talent mix in your team. Then set these things you should fix in the planning time. Then when it comes to checkpoint, you should fix the checkpoint. Suppose if you identify any kind of errors, you need to roll back from a previous point, and again you need to restart your work. So we need a safe zone to roll back. That point is called checkpoint that you can fix at the time of your planning time itself. The next is apply software engineering techniques. We can apply many techniques for either gathering information or project estimation. There are many methods and systems are there, like interview, FAST, that is for gathering the information, and project estimation also. Their software, source line code is there, SLOC, source line of code is there, and SP function point calculation is there. That is for project estimation, to identify the length or complexity of project if you count the line of code. And functional point is another formula is there. We know how to. I will explain when, if it would be there in your syllabus, how to calculate the functional point. We should consider some parameters, and based on the parameter, we can do the project estimation. The next is executing formal technical review to identify the errors in the early phase. So this part we learn detail. Then having multi-testing strategy, because one single testing strategy is not sufficient to count all the errors. So we can go for multi-testing strategies to make sure that your product is tested in all angles. Then enforcing process adherence. Once you start your project, you should not change the process. You should stick on one particular project and its process and its standards. Then control the changes. Generally, we should not control the change, but whenever there is a need, like evaluate the nature of change and control the Then you can control the change request. While validating itself, you can identify is it needed? What is the impact of the change made in your project? If it is a huge impact, reverse impact, you should not go for that. So you can control the change. Then measure change impact and how much impact once you make some modification on your module, what kind of impact it create overall system or the particular module that you need to study. So that is the change impact measure. Then performing an SQA auditing actually we are doing, we are complying, how we are comparing it with the existing established process and check whether reported by the team in the status reports were actually performed or not. If it's not performed, you should suggest it again, and this activity exposes any non-compliance issues are there, it will expose that thing. So this part is called auditing. Auditing is like when we are doing a auditing for a company, they will check the economical side, right? They will go through all the things, whether it made, is there any excess resource utilization. When it comes to software, we are checking whether the status reports are correct or not, or whether they done this performance, whatever they are suggested here, it's already performed or not. Then maintain a record and report whatever you have done and manage a good relationship and harmony between the team members. If there is a problem with team member, the quality, it will create an impact on your product also, because it's a group work, it's not an individual work. So the team members' harmony and cooperation is very much important. So these 11 points you need to remember as SQA activity. Create an SQA management plan, set the checkpoints, then apply software engineering techniques and execute formal technical review, having a multi-testing strategy and enforce the process adherence, control the change, measure change impact, perform SQA audit, maintain records and reports, manage good relationships. These are the 11 points called SQA techniques. SQA task, software task. Next is SQA techniques. Techniques actually, it's belong to the software quality. Software task. In the software task, auditing, review, and code inspections are there. These three are called techniques. Auditing means, when we are doing auditing a work product, actually we are doing some inspection, whether that particular product uses some standard process and whether it followed or not. That will check in the auditing time, and whether it matches the status report or not, whether they have done or not, what is the outcome that we are checking during the auditing time. Then review means a meeting, formal technical review, what you learn, the same thing only. We are taking the feedback from the stakeholders. And code inspection, to find the bugs and avoid defective growth in the later stages, and it's done by trained mediator or peer. That's based on rules. Code inspection is always following some rules and standards. Checklists are there, entry exit criteria is there, codes. The reviewer should not be the author of code. Means when you write the code and you are doing one testing, that testing is not called as code inspection. Code inspection generally is doing by a third party. So when you wrote one program and immediately you are checking whether it's working correctly or not, that is the first testing actually, before it hand over to the product to a third party. Internal inspection is there. But again, we need an external inspection. Internally, if you're checking your code itself, it's not called as inspection. Okay. Then what are the elements of software quality assurance? Software engineering standards, technical review and audit, software testing for quality control, error collection and analysis, change management, education programs, vendor management, security management, safety management. risk management. These are the elements of software quality assurance, because software quality you could not achieve by simply modifying something on your final product. You have to follow the standards from the initial phase onwards, then only you could, and will go through all the stages: risk management, safety management, security management, vendor management. Then only you could say that the software quality is very good. Then in the next class, I will teach you statistical software quality assurance. In statistical quality assurance scheme, collect and categorize the information about software defect that occur. These are the 3 steps. Sir. First, you need to collect and categorize the information. Which information regarding what are the causes that create a defect in your software, and what is the impact? Based on that, you can categorize the different causes. Then attempt to trace each defect. So its underlying cause. You should find out the underlying cause, whether it is due to non-conformance to specification or design error or violation of the standards or poor communication. You should identify what is the exact reason for that error. Using the Pareto principle, actually every single project is a teaching for you. You have learned something from that you can apply in the future projects. Using Pareto principle, you can isolate 20%, which means 80% defects are created by 20% program modules. So find out the error-prone areas using Pareto principles, and you can try to avoid the 20, isolate the 20%. Everywhere this problem is there, not in the case of software industry. Everywhere the 20% people are making problems wherever, in whatever cases you take. That's why this 20-80 rule or Pareto principle is very, very familiar, and it's very popular one. The same principle we are applying in different domains. When it comes to a road accident, 20% vehicles are creating problems. Really, remaining 80% actually does not create any problem. They are following things. When it comes to an organization, when it comes to a classroom, in every organization, you can apply this rule 80-20%. Recently, one article, I noticed one fashion designer is saying in Pareto principle is using in the fashion industry also. Like you have so many dresses, but among all dresses, just 20% dresses you are using on regular basis. The remaining 80% you are keeping in your shelf without using for a long time also. So the principle is everywhere. That's called Pareto principle. So when it comes to software terminology, what is software context? 80% defects are causing by 20% modules. So identify the error-prone area and try to remove that. So this is a statistical software quality assurance. There are many methods to statistical quality assurance. So I will discuss in the next class. So what about, I will listen. I will listen to the class this last hour. Anybody is there out of 38 students? Many people join without audio. Lakshmi Akhila, number 11, Sanjay, Diksha Reddy, Manish Reddy, Pavan, Sheikh Mohammed, Siddharth, Nikita. This many people, they join without audio, they are not even listening. So next is, actually I stopped my class, but before going to wind up the session, the next class I will teach you on Six Sigma. That is one of the quality assurance methodology that I will show you that video. There is a nice video found from YouTube. I will play that for you, but that is just I think 8 to 9 minutes are there, the videos. Listen, and after that you can leave. Tell me, is it audible or not?
Company you're working for produces luxury cars. Imagine you've been tasked with a really important project at work.
Is it audible? No.
Company you're working for produces luxury cars. The production numbers are going down, and a lesser number of cars are getting manufactured each day. There also seems to be an issue with the quality of the windshield wipers that go on these cars. The question you are faced with: is there a way for the company to stop the stall in production and increase the production per day from 1,000 to 2,000? Also, is there a way to find out what's causing the drop in the wiper quality? There is. Six Sigma. Six Sigma gives you the tools and techniques to determine what's making the manufacturing process slow down, how you can eliminate the delays, improve the process, and fix further issues along the way. The concept was introduced in 1980 by Bill Smith while working for Motorola. Since then, Six Sigma has seen worldwide adoption. Six Sigma aims to reduce the time, defects, and variability experienced by processes in an organization. Thanks to Six Sigma, you can produce a defect-free product 99.9996% of the time, allowing only 3.4 errors per 1 million opportunities. Six Sigma also increases customer loyalty towards the brand, improves employee morale, leading to higher productivity. Six Sigma has two major methodologies, DMAIC and DMADV. Let's look at the first methodology. DMAIC is an acronym for Define, Measure, Analyze, Improve, and Control. Let's have a look at each of these stages individually and how it relates to your earlier problem. In the Define phase, you determine what issues you're facing, what your opportunities for improvement are, and what the customer requires of you. Here, you look at the process as a whole and determine the issues with the manufacturing process. In this case, finding out why the cars had varying windshield wiper quality and how to optimize the current process to manufacture more cars. In the Measure phase, you determine how the process is performing currently in its unaltered state. You determine the current number of cars that are manufactured in a day. In the current scenario, 1,000 cars are manufactured in a day, and each of these cars are outfitted with a pair of windshield wipers by one of 30 machines used. Some of the metrics measured are how many cars are produced in a day, time taken to assemble a car, how many windshield wipers were attached in a day, time that takes them to do so, defects detected from each machine on assembly completion, and so on. Following this, in the Analyze phase, you determine what caused the defect or variation. On analyzing previous data, you find out that one of the machines that installed the windshield wiper was not performing as well as it was supposed to. Production was taking longer since the car chassis was being moved across the different locations slower, as cranes had to individually pick and drop the frame. This was because the wheels were attached to the car only in the last stage. Next, in the Improve phase, you make changes to the manufacturing process and ensure the defects are addressed. You replace the faulty machines that installed the windshield wiper with another one. You also find a way to save time by attaching wheels on the frame in the initial stages of the manufacturing process, unlike how it was done earlier. Now the car can be moved across the assembly area faster. And finally, In the control phase, you make regular adjustments to control new processes and future performance. Based on the changes made, the company was able to reduce production time and manufacture about 2,000 cars a day with a higher quality of output. DMAIC is one of the most commonly used methodologies in the world. It focuses on improving the existing products of the organization. The second methodology is DMADV, which is short for Define, Measure, Analyze, Design, and Verify. It is used when the company has to create a new product or service from scratch. It is also called DFSS, or Design for Six Sigma. Let's take the scenario where the company decides to build a new model, a sports car. In the Define phase, you define the requirements of the customer. Based on inputs from customers, historical data, industry research, you determine what you need to ensure your car becomes a success. The data collected indicates customers are drawn to cars which can achieve more than 150 miles per hour. Customers are also more inclined towards cars which have V6 engines and an aerodynamic frame. Then, in the measure phase, you use the customer's requirements to create a specification. This specification helps define the product in a measurable method, so that data can be collected and compared with specific requirements. Some of the major specifications that you focus on are the top speed, engine type, and type of frame. In the Analyze phase, you analyze the product to determine whether there are better ways to achieve the desired results. Areas of improvement are determined and tested. Based on the analysis of the prototype created in this phase, you find that the product satisfies just about all of the customer requirements, except the top speed. So, research begins on an aluminum alloy that could possibly meet the speed requirements of the customer. Following this, the design phase. Based on the learnings from the analysis phase, the new process or product is designed. Revisions are made to the model, and the car is manufactured with the new material. The analysis phase is repeated based on the new design. You also bring a focus group and see how they receive it. Based on their feedback, further changes are made. And finally, in the verify phase, you check whether the end result meets or exceeds customer requirements. Once you launch your brand new sports car, you collect customer feedback and incorporate it into future designs. And guess what? Your customers are loving the new design. And that is DMADV for you. Six Sigma has also found success in a number of different industries. The petrochemical, healthcare, banking, government, and software are some of the industries that have utilized the concepts of Six Sigma to achieve their business goals. Another commonly used methodology adopted by companies around the world is Lean. Lean is a methodology that aims to remove any part of the process that does not bring value to the customer. It means doing more with less while doing it better. The philosophy behind Lean comes from the Japanese manufacturing industry by Bob Hartman, who at the time was part of Toyota. Since then, across the world, services and manufacturing organizations have incorporated Lean within their businesses. But what if you could have the best of both worlds? A combination of both Six Sigma and Lean. That's Lean Six Sigma. Before we get into Lean Six Sigma, we've got a quiz for you. What methodology is used by companies when they want to release a new product created from scratch? A. Design, measure, analyze, define, verify. B. Define, measure, analyze, design, verify. C. Demand, measure, analyze, improve, control. D. Define, measure, analyze, improve, control. Leave your answers in the comment section below for a chance to be one of 3 people to...
Have you listened to this video? This is what this, how many of you will listen this? I don't know. But this video is very nice video. It represents all Six Sigma concepts, how to improve the quality of a product, how can make sure that product is a quality product. For a new product, that is one model is suggesting for creating a product from a scratch, another from an existing product. So those two. DMAIC and DMADV. DMADV for a scratch, a new product, and DMAIC for an existing product. DMADV. This is the last question answer. So everyone go through this Six Sigma video lecture. It's a very nice video lecture. I present all concepts. So if anyone missed this, I'll share the link in WhatsApp. Okay. So I hope everyone listen. Thank you. Okay, I'm going to stop the session.